Let's go ahead and get started. I'm sure there'll be a lot more that come on as we get going. Um, just a little bit for those of you already here, a little bit of housekeeping here. Down on the bottom of your screen, there's a Q&A box, and we encourage all your questions to be typed in there, and we'll address them afterwards. So welcome to Webinar Wednesday. We've been doing this for several weeks now, every week, and it allowed us to really reach out to our customer base all over the place a little bit better. Really good topics we've had. Today's topic will be vaccination in the hatchery, and Dr. Josh Deines from Zoetis will be joining us. I've known Josh quite a few years, originally from Colorado, came to Arkansas when I was there and did his graduate work, and has done really good things in his graduate work and also in his new position with Zoetis. So he'll be our speaker today, and just in advance, we will have a promotion for next week. And next week we'll have another webinar, and that will be on maintenance and troubleshooting in our single stage hatcheries. And you might learn some things about maintenance troubleshooting if you even don't have single stage, but it will be specific for that. So with that, let's go ahead and let Dr. Deines go ahead and start with this presentation. At the end of his presentation, we'll address the questions that you have. Also, at the end of after the presentation is done, probably in the next 24 hours or so, you will get an email from Jamesway that'll have a link to this recording, so you can watch it again later, and you know, at a slower pace and get some more information out of it. But also, you'll get a PDF of the presentation itself, so you can review it a little bit after that. So. With that, Josh, you will go ahead and take over, and we'll let you go for it here and see you when you're all finished up. Josh.
All right. Sounds good. Thanks, Dr. Bramwell, and thanks, Jamesway. I appreciate you all letting me come on to present. I've heard a lot of good things about this webinar, both from common customers that we share, and then also from a lot of my colleagues who've been participating in these themselves to learn something. So this morning, we're just going to spend some time talking about vaccination in the hatchery, and we'll spend a lot of that time in in vivo vaccination because that's what we predominantly do at Zoetis, and it's a very common method in the United States. And I kind of want to put this whole thing into light of vaccinating in the antibiotic-free world, because we've lost a lot of our band-aids and some different tools that we used to use in the hatchery. And so I think it's important that we get back to some of the basics of fundamentals, managing a good, well-run hatchery, and really focusing on sanitation and good vaccination practices. So hopefully there's some good tips and tricks that we'll discuss this morning that are helpful for you if you're doing in ovo or if you're doing some other kind of vaccination program as well. And the first thing that we need to talk about is, why do we vaccinate in the first place? And of course, we want to get rid of diseases. And so one of the main vaccines that we use is for Marek's, because it's such a common disease and has created so many problems. So if we look at this graph here, this is going to show us why vaccination is so critical and really what it's done for the industry as a whole. So if we look at this from 1960 to 1970, Marek's was really on the rise in the United States. It was decimating birds, you're having condemnations, all those things, boom. Then around 1970, once you get that vaccine coming on board, you can see what it did and how many birds it saved. And this projection says that 2 billion chickens have been saved strictly because of vaccination. And I'd say that's probably a very modest estimate of birds saved. And we could see that trajectory going out to about 2,000. Well, we're 20 years beyond that, and how many birds have been saved? Keep in mind that in the initial part of this graph, production was a lot lower and smaller scale than it is now. So Marek's is something we overlook now. We don't think as much about or worry about, because vaccines are doing their job so well, that they've been so effective. We don't think about it. It's kind of in the back of our mind, but we need to think about how critical that is to production still. So for instance, if we think about Marek's, it's a bad disease. It's very infectious. It has immunosuppression, and we'll talk a little more about that later. It could also have neurological problems and signs, skin lesions, and visceral tumors. So this is where you're getting your condemnations at the plant. And because of all those things, yes, it's really bad for the bird, but it also has a huge economical impact. In fact, it's one of the worst in the industry, at an estimated over $1 billion loss every year just because of Marek's. So if we look at how this disease progresses, It's everywhere, and that's because it's in the free dander from the birds. This feather dander, as the bird matures, that virus is being shed through the dander. So it's in the air, and it's really almost impossible to escape. So that's why vaccine is the best way to control this disease. The birds then inhale it, it settles in the lungs, and then once it gets to the bursa, that's really where you see a lot of these bigger problems occurring. For instance, it's going to impact the immune system. So if we look at our B cells, that impact is going to create immunosuppression. Now, this part of the disease we don't understand quite as well, but we know Merrick's is suppressing the immune system pretty poorly. So we'll talk about that more later on. But the thing we know more about that the vaccine really protects for is this latency. It protects from the tumors, the paralysis, and then limits some of the shedding. So the vaccine does really, really well. But if you're not vaccinating and Merrick's is prevalent in the area, that immunosuppression is really what's going to impact the rest of production, our growth rate, feed conversion, those kinds of things. And that's what we need to understand more about. If we think about the vaccine, when we do it in novo, it's going to create really early protection. So here, just kind of a quick illustration. At day 1 of hatch, in novo vaccination of Merrick's already has about 70% protection for that flock. And if vaccination occurs at hatch, it takes about 5 days to catch up to that same level of protection. So that's why Merrick's, it's everywhere, and in novo vaccination is one of the best ways to protect your birds from that disease. But beyond that, in novo is going to provide a lot of other benefits in vaccinating. We talked about that early immune response and protection, not just to Merrick's, but to other diseases that you could vaccinate for. You're beating that hatch time and exposure. You got about 3-day head start. You're going to reduce the bird stress because there's no handling of the individual birds. And if you think of all the methods of vaccination, it's one of the safest, fastest, most consistent and uniform vaccine method that is out there. And that's why it's so prevalent and so many people are using this methodology. And because so much of it is automated, you're having an increased labor savings. And what this comes down to is all these things accumulate and improve hatchery efficiencies, chick quality, and ultimately performance in the field. So profitability, good things we want to see. That's kind of a quick introduction about in novo vaccination and why we vaccinate, specifically Merrick's. Now let's talk about some of the interactions that vaccination has and some key places to look. So if you see here at the top, we have our performance parameters, what we're really trying to capture. We want good chick quality, we want high hatchability, and low early mortality. That's our goal in the hatchery. And so there's kind of 4 areas I'll be focusing on and how to achieve that and how it relates to vaccination. One is the actual in novo vaccination process itself. Number 2 is egg pack quality, what eggs are coming in, because that's what we're going to have to deal with at the hatchery. We can't change that once it's there. Sanitation, huge piece. We'll spend a lot of time there. And lastly, incubation. That's another critical piece in this whole component of hatchery vaccination, specifically in an antibiotic-free world. Let's start with egg quality. This is what's coming in. It's the first step. Here's a couple of examples. We've all seen these. These are very exaggerated, some of the extremes, everything from dirty egg to blood-stained, chalky, wrinkled eggs, a lot of different things coming in. And what we have here is what we're going to have to work with, not only to achieve hatch and to incubate, but also what we're vaccinating. So everything that is on these eggs could potentially enter that egg at vaccination. So we need to always have that in the back of our mind. So the key here is the eggs, some sort of process needs to be in place to monitor them and to create some sort of check and balance. So how often are you checking your egg pack quality? Is there a formalized assessment in place? And how is that information being used? So I recommend not only to check these, but to have good communication back to the breeder farm so that improvements can be made, and to be methodical about the evaluation. So checking each flock specifically and each farm as well. So that's one tool, is to have an egg pack assessment. There's a lot of other things you could do, such as cuticle staining. That's just one QA tool that we've tried in the past. Staining an egg and seeing what your cuticle quality is like. Here's a few other areas to check for on the egg pack quality. We'll briefly check on all these. The first we already kind of hit on, dirty eggs, contamination. What are you culling towards? What is your standard of what is dirty and not? And how are you capturing that data and sending it back to the breeder? So that comes back to sampling protocol and frequency. The other way is, how are we handling our eggs? Once we get those in, we got to take good care of them, because what happens early on, before that egg is even incubated, will impact all the downstream effects. So temperature from collection, that includes on farm, during transport, and also once you get to the hatchery, that egg room. And it's been shown in the past that not only is the temperature that those eggs are at important, but also how consistent is that temperature kept. Some of those slight fluctuations of 2 degrees or more can often be more impactful and challenging than having a bad temperature in itself. So consistent temperature and holding it there within 1 to 2 degrees. And also having those eggs in the egg room being positioned well is going to help with temperature and airflow. So here you can see ventilation, that's going to be critical. You got to have that airflow to get through so that they all have consistent, uniform temperature. And a lot of times we'll go in the hatchery and we'll ask, hey, what do you keep your egg storage room at? And there's often an answer, which is a good, correct temperature. However, you pull out the Kestrel or your own device and realize that maybe it wasn't calibrated. So one quick, easy check to do is say, hey, how are you monitoring the temperature in your egg room? What tool are you doing it with? And have you calibrated it and checked it to something else? It can't just be a set it and forget it, but something you need to come back and check frequently. So a Kestrel or some sort of environmental measuring device can be a great tool to help out there. Egg room sanitation. We'll be talking more about sanitation later on, but the egg room is not a place we can forget about. Under all those buggies, crack dropped eggs, and keeping it segregated. So if you come in and you're sorting eggs from your culls or dumps, keeping them away from your good eggs that you're going to be setting. And if you follow these things well, good methodology, you'll have a more uniform hatch, and you'll also have lower early mortality. So keep that in mind. Now let's run through a quick scenario here. We talked a lot about dirty versus clean eggs. Let's go into kind of a theoretical example of how this looks in your hatchery. So let's say you have 15,000 eggs. You're going to set those in your hatchery. And it's kind of an average flock. You look at them, do a visual evaluation, determine that 99.5% of those eggs are clean. And 0.5% we would say is dirty, just by visual observation. So if we look here, it's a lot of complicated math. Let's just go into the theory of this, and we won't have to do any hard math this morning. But those eggs that even appear clean, we know that just because it looks clean doesn't mean that it has no bacteria on it. There's still something on that egg, even if it looks clean. So there we can see how much bacteria is on it. And then down at the bottom, we could see how much bacteria is in that hatcher from those 0.5% dirty eggs. So we could see our total incubation at start of incubation, our total bacteria count is 3 × 10⁸ CFUs of bacteria. Now of that, 20% came from the dirty eggs. So just 0.5% of all the eggs in the incubator represented 20% of all the bacteria in there. And fast forward 18 days to transfer, we see our post-incubation bacteria count. Now these clean eggs, if there's no organic material present, we're incubating right, the setters we keep pretty clean, that should actually decrease in count. Those eggs should decrease in their bacteria load over time. Now if we look at the dirty eggs, it's just the opposite. There is organic material there present, and their bacteria is actually going to increase. So even though the clean eggs, which was the majority, decreased in bacteria count, our overall load in that incubator increased to 1.6 × 10⁹ CFUs. So now at transfer time, we're looking at 94% of all the bacteria in there came from just that 0.5% of dirty eggs. So that just goes to show a few dirty eggs in there is really increasing our pathogen load and exposure. And all that bacteria is going to go into our hatcher and going to expose our chicks. And if you're in ovo vaccinating, those dirty eggs and all that bacteria in there is potentially being punched or put into the eggs. So something to think about and really be cautious about. So moving on a little bit from this bacteria and clean egg section, we're going to switch over to incubation. So these are your eggs coming in from the egg pack. Let's talk some about incubation. And I'll kind of emphasize one point on that, and that is hatch window. So that's our spread of hatch, first chick to last chick, how uniform that process is and what that curve looks like. And then here's talk a lot about that for a lot of reasons. One, it's going to impact chick quality. Those early hatching chicks, you don't want to dehydrate while you're waiting for those last chicks to get dry. And same thing, if you got a really wide hatch window, you're going to have a lot of green chicks and a lot of dehydrated chicks. So tighten up that window is going to improve chick uniformity and quality. But also, if we think about our uniformity of hatch, let's back up 3 days to time of transfer when we're vaccinating those embryos. That same spread in that snapshot of vaccination time is going to exist. So if we have a really wide hatch window, there's also a lot of variability in embryo development phase at time of vaccination, which means that some embryos are not very far along in development and some are very advanced at time of vaccination. So not all of them are getting as uniform of a vaccine delivery as what we'd like to see, meaning that some will be vaccinated in not the correct location and have not as good vaccine efficacy. So the better our hatch window, the better our vaccination and hatch. We can see a couple graphs here that kind of illustrate that. On the very left, we can see the staging of those embryos. And this is kind of a methodology that we use at Zoetis when we're looking at how far in development is that embryo at time of vaccination, which has everything to do with set time, transfer time, and uniformity. And so if you ask your technical service representative, your TSR from Zoetis, they may have provided this service for you. And if you want to know more about it, they can help you out. But we take these embryos at vaccination and say, hey, what stage of development are they? And we score it from 1 to 7 here. You can see that. And depending on when you transfer, they're going to be in different phases of that. So for instance, let's take the green line at a 19-day transfer, and we can see the bulk of them are at a number 4 development stage, and then you have tails on either side. And depending on how well your incubation program is and how well you handle those eggs, that curve might be tighter or wider and flatter. So that's something to think about and try to adjust. And a good way to monitor that on your own is to do a 12-hour pre-pull. So this is 12 hours before your pull time. Go into the hatcher, open up some baskets, and look at those chicks. So here we can see an example of prime flock. 70 to 80% of those chicks should be hatched out at that 12-hour time period. And then that'll just assure that you have enough time for those green chicks to dry out, but before your other chicks are going to get dehydrated. And then during those remaining 12 hours, you can just regulate, keep those birds comfortable, and then they'll be ready to pull off. And if you want to help troubleshoot this, if it's not quite right, that's why you have your resources as far as your consultants at Jamesway. They could help troubleshoot your incubation, your machines, your profiles, all those things. And as well, this is going to impact your vaccination. So reach out to our TSRs and they can help you adjust some of this and see if it's looking like it's in the right spot or not. Now keep in mind that every time we do a 12-hour pre-pull or we're looking at these birds where they're at in embryo staging, it has to do a lot with location and uniformity. That's really what we want, is good uniform birds for vaccination and chick quality. So when we're doing this 12-hour pre-pull, or when we're doing a site of injection analysis, looking at multiple places in the hatcher. You don't want any cold spots or hot spots. And if you look around at multiple baskets, you might see that. So how do you alleviate those problems? And any other incubation questions we can kind of save for the end. I'll just kind of brush on that a little bit. We're on Jamesway column. I know they have a lot of really good information on their previous webinars you could check out. So I really want to spend more of our time on sanitation. This is such an important piece of a hatchery as a whole, especially when it comes to vaccination and in ovo. Because whatever is out there could potentially get inside of that egg, get inside of that chick. And when we vaccinate, sometimes you could be putting it into the egg. So let's make sure that we're operating in an optimum sanitary environment. First place we want to look is our hatch baskets. Make sure they're good and clean. So here on the left, these are supposedly clean baskets, but we could see all the organic material on there, the feces. It's a lot of bacteria and a lot of place to keep them living for a period of time. And so we put this on our presentation, can you eat off of the hatching basket? But as we know, most of us who work in hatcheries and involved in agriculture, we've ate a lot of things we shouldn't off of a lot of things that we shouldn't be eating off of. So I think we should actually be asking the question instead, would your mother be eating off of that basket? She's probably going to be more picky than we are. You want to keep those baskets good and clean, because not only are our eggs with a hole in it being set on those, but then our chicks, when they hatch, they're being exposed to everything on it. How about this? This is the hatch baskets that transfer on our Innovo device. What does that tell you about the tray washing process? Look at all that organic material that's on there. That's a red flag sign. So when we keep our baskets and trays clean, it all comes down to the wash, how we're taking care of it. And the first thing to emphasize on is the temperature, 135 to 145. This allows for whatever chemicals you're using to be at a good operating temperature, keeps the bacteria load down, but it's not hot enough to be hard on your equipment and your baskets. And whatever product you're using as far as detergent, I think it's important to have a continuous feed and to monitor those parts per million and your pH. It's also a good idea to rotate your alkaline and acids in the tray wash. So a lot of times you could do 3 to 6 weeks of one and then switch to a week on the acid. That'll help remove any buildup that's happening and any residuals that are left. Having a final disinfection, a dip or a spray, and again, monitoring the ppms is critical throughout the day because it could be diluted, so you want to keep checking that. And another key part to this is heating and or drying the tray wash after cleaning. So that'll keep anything from residing overnight and continuing to grow in there. Next area that we want to focus on is our water quality. So if you have a problem here, there's a lot of different people out there that could help. And we could offer some advice and places to check on for that. But you're not going to know what your water's like if you don't test it. So that's the first step, is check that incoming water, because you can't just trust the city water. Or if, oh, well, we got a pretty good well, don't just assume that it's good. Check it, see what those parameters are. And not just on the bacteria, but also your pH and whatever else is in there, because what chemicals you're putting in is going to be impacted by the pH of that water. So make sure to get it checked, check it coming in, but also you need to check it at the end point, because our water is so important in the hatchery. It's going to be in our hallways, it's our incubation and humidity, and it's in the lab, and we're using all of that. So checking all those endpoints, because if you check at the source and say our water is good, or hey, we just put in a brand new treatment system, and when it comes out of that, our water is great. Well, did you check it at the humidity system? Because if you have active chlorine at 0 or 1 part per million coming out of the spray, it could be getting bound up in the pipes, or the pH could be off, or something else is happening in the system. So make sure to check it at the endpoints as well. Kind of another area to check out for sanitation is your air handling system. It's often forgot because sometimes it's harder to access. And so one thing to think about here is, hey, how do I make a system that forces me to be on a program to check it? So some sort of QA where on a regular basis they're being checked, and these machines are being put in place where they're more accessible to get to. So seasonal startup and shutdown, checking those insulation materials. What kind of filter type do you have? Is it accessible? And how often are you checking it? Those are just a few key points. I won't spend too much time on this, but I want to visually show an example of why this is so important. If we look here, this is an HVAC above the chick room. We can see so much red there being captured in the filter. And that's the spray vaccination. So that just shows how dirty this can get after a day. Now imagine if you're letting this run multiple days or weeks, however often you check it. And this is dyed vaccine. It's really easy to see. So think about all the bacteria and things that we can't see and how much of that is in there if we're not daily looking at these filters, exchanging it, and having some sort of QA process and check. Because whatever air comes through here is going to be circulated into the hatchery and exposed to those chicks. So those are a few areas of sanitation we can focus on: our water, our hatch baskets, and our HVAC systems. And so now let's kind of get into the meat and potatoes of this, which is the vaccination procedure and how to optimize that in our hatchery. And sanitation is going to be very important here as well. So let's spend some time talking about the device itself. And the key thing about the device, of course, is cleanliness. You're not going to know it's clean or not if you don't check it. So we encourage management to check in on the device and see what that cleanliness is like. And it's the best time to do that is during storage, because it should always be put away clean and dry. So here we can see if, check it every day. Try to do that. And we want to look at the carts, the We want to make sure that the spigots are clean, the containers being upside down and dry. And if we look here, this is just a quick checklist, a couple things to check out. At shutdown, this is what you want to look for as a manager, coming in, inspecting the device. The cleaning cart containers should be clean and dry, and upside down is going to help with that. Have those spigots open. We want our alcohol stored in the sanitation system, and that's just going to keep things from growing in there. We put it away clean, put that alcohol in the system to keep more things from coming about. We want to remove those spigots once a week, give them a good clean with some diluted bleach. Want to check the vaccine lines, make sure there's no residual vaccine left in them. And that's where the dye comes in handy, just a quick check for those. Checking out the transfer head, make sure that the cups are allowed to dry, no organic material present. Another good place to check is the vacuum elbow. Visibly, it should be clean, and the hoses should be stored in a manner that they're able to dry. Make sure there's no organic material present on anywhere on the machine. Just give it a quick look over. And the best way to keep this clean is to get it dry as well. So after this good wash down procedure, put it in a good stored place, as we've discussed, and having airflow. That'll help dry it out and kill anything else that is on the machine. Let's look at a few examples of what we don't want to see. If we look at the one on the left, we see this is the alcohol container, and at the bottom, we see some debris and eggshell present. We don't want to see that. That means that it wasn't getting cleaned out right, and that's going to be in the system the next day when we go to vaccinate our eggs and embryos. So that's why during storage is such a good time to check, because whatever we see at storage is going to be there the next morning when we start up. Look at the cleaning cart spigot there in the middle. A lot of gunk growing in there. We don't want to see that. Get those good and clean. Get some bleach and a scrubber. Also on the right, we could see the vaccine lines, and it might be kind of hard to see on the screen, but there's blue still in there. We want to make sure that there's no residual vaccine left. Make sure to flush it out well. So that's kind of a few tips on the device itself. Let's jump over and talk a little bit about the preparation area. This is somewhere we want to be really clean, because that vaccine, how we prepare it, that's all going to be going into that embryo. So keeping it good and clean. Here's just a couple of pictures on the top. We want to see a good clean workspace, countertop, free of clutter, washed down, plenty of room. And same with the thaw bath. It's a critical area. Every vial that we thaw is going into this unit. So why not focus on it and keep it really clean, whether it's a poly unit or a stainless steel. If we're having issues in the lab and we think that, hey, how else can we control our filth in there? Well, the first thing is to limit traffic flow, who's going in and out. Set up a dedicated workspace. And if that's not always possible, or you're waiting on some funding to upgrade your lab and vaccine mixing area, what are some other things you could do to help out? Well, one is to put a floor mat. If you could see in this example, it's a sticky floor pad. And whenever somebody walks in, it's going to help get that material that they're tracking in off of their feet, so they're not tracking it around the lab, especially dust, something that could be blown up and aerosolized, sticking to that mat. Maybe it's just a quick refinish of your floor as well, putting some epoxy down, making it easier to clean, a little less porous. And if you're looking for a different workspace, a way to contain that area where you're mixing the vaccine, what about a laminar flow hood? This creates a dedicated area to work in, keep a good clean workspace, separate it from whatever else is in the mixing room, and have good clean air to be working with, so that you're not introducing any pathogens or contaminants to that vaccine process. You want it to be clean. So in all this time we spent talking about cleanliness and sanitation, it may look clean, but how do we ensure that it actually is? And so let's spend a moment talking about sampling. This is the way we can find out. So I encourage everyone to have some sort of process in place internally, QA, and actually use it on a regular basis, gather that data, and make choices based off of it. So not just sampling, but actually using it to your advantage. And if you need assistance getting microbial sampling at Zoetis, our field service guys, our technical service representatives, they can all assist with this. And many of you are receiving these services on a regular basis. So help with that data and put it to good use. Here's a few places that you want to test and check out. Starting in the lab. Again, critical area, our vaccines are being mixed here. Checking the tap water, checking the countertops, or thaw bath, mixing that vaccine and then checking it, making sure that you're using good aseptic technique, checking the ventilation and airflow, and those ice packs. That's a place that we see that's really dirty a lot of the time. Also, if you're storing anything in the refrigerator, make sure to check the handle on that and inside the refrigerator because you're storing things in there that you're using. How about the Innovo device? That's a good place to sample as well. We do this a lot. We sample, see how well that cart is being cleaned, how well it's being stored, and where it's being stored is going to play a huge part in that as well. So checking every part of this, the sterile water, the saline through the device, the vaccine, the spigots, the cleaning cart, the transfer cups, they should be clean and dry when you sample, and hopefully they're coming back with no pathogens on there. Now, the key thing to keep in mind when you're sampling here is to also do an air sample while you're collecting these samples, especially the fluid, because what else is floating around in that sampling area that wasn't a result of the device and your cleaning, but you're bringing into the air. So treat it kind of as a control and get a good air sample there. All of these things that we're monitoring, we want to put in place in some sort of operation checklist, quality control, have it a standardized procedure. So let's focus on a few areas to monitor. We want to monitor the personnel and performance during the egg set. So looking for egg cracks, egg temperature, and the transfer process. So those are three areas to really focus on our monitoring in our QA. We want to pay good attention to some of these areas as well. So think about our embryos. Remember we talked about that hatch window. How long does your transfer process take and across an age of a flock? So the first embryos going through compared to your last, how are those stages different? And how is that temperature different? Are they being held out for an excessive amount of time and we're losing a lot of embryo heat? Something to pay attention to. How about the environment that this injection and transfer is taking place in? How's the airflow? What's that quality like? And what is the temperature there? And you need to pay that same detail to the hallway doors and then cracking. That's another place where we see a lot is at the transfer table, slamming the baskets, putting them down too hard, uneven floors, just another place to have some good quality control. So something to keep in mind, and a good thing to do is use the process checklist. These are things to check while you're vaccinating at every bag change. Ensuring that the tooling is locating on the egg properly. Make sure that it comes down onto it. You have contact, it's not crooked, that tooling isn't stuck. That's one good thing to look for. The second piece of this checklist is looking for bent needles, really critical. Doing this all high frequency, every bag change, every bent needle is going to potentially create an extra cracked egg that could be either more impacted by pathogens or have lower hatch in those eggs. And if one needle is bent, think of how many runs you're doing. That one needle adds up to an egg every single drop down of that head. So it adds up over a day. So make sure that you're not getting any needle punching or you don't have any broken punches. And we'll show a few example pictures here in a moment. How is that tooling coming down those cylinders? Is it slow? Are any of them sticking? Check for that. How about on the egg surface? Are there star cracks? Is there a good punch? And is there any vaccine present on top of that? You don't want any vaccine at the top of your eggs. Checking for fluid leaks. Look at the top of your heads. Is there any fluid leaking? Something that needs to be changed, tightened up? Also, at the end of at every bag change or when we run QC plate, clean and dry those identifiers and those eyes. And that will just make sure that the machine keeps running and that you could stay on pace and schedule. Also, after every buggy, using a QC plate, going through, making sure that every needle is in fact dispensing vaccine and sanitizer, really important. Also checking for vacuum cups, making sure that none are clogged, and also checking the transfer table there as well. Here's a couple examples. Getting down at eye level is going to be important here, making sure those heads are locating properly onto the egg there. So you can see here all of them have contact. They're all going down all the way and none appear to be super crooked. That's what we want to see. How about this? Bent needles. This is a good example. On the left we see a needle that's obviously very bent, and every time that needle goes down, it's going to probably crack the shell a little bit, and it may be clogged. It may not even be dispensing at that point. So changing those out is really important. The price of a needle is not much, but the impact that that bent needle has on those chicks is expensive. So check that frequently. Here's what we want to see on our eggs. If we look at the left, we can see a good punch that happens. Remember, we're using a dual needle system, which is the best for keeping the shell in good contact, and it's also good for sanitation. So that's why we have that 2-needle system. And we have that punch. It creates a nice, perfect little ring, and then allows the needle to go in, keeping it safe and not being exposed to the shell. Whereas on the right, you can see it didn't get punched, but the needle hit that shell, which means you're going to bend more needles, and you're also probably going to get more bacteria in there or more organic material that could potentially clog it. So we want to check on that all the time. Vaccine on the egg. Here's an example. If you see just a little ring potentially every now and then, it's not a big deal. That can happen. But when we see those big blue droplets coming out of the vaccination hole on a lot of the eggs, that's a problem. And it could mean a few different things. So reach out to your field service specialist. They could help you troubleshoot it. But maybe there's not the correct pressure going. Maybe you have a lot of bent needles that are clogged up. Or maybe your embryo staging is not at the right place, and you're clogging up with the chick. You're hitting an embryo itself instead of the amnion. That can happen as well. So there's some different factors to think about here. The key thing is how much vaccine is on the outside of your egg. And if you see this, there's a problem. So get it checked out. All right, so looking at the injection heads, we can see here there's a lot of droplets on top of the whole unit. And then if we see where the vaccine line comes in at the top of the needle, there's a little bit of liquid up there. So we could have a couple different leaking spots on this head. So is it a line? Is it the needle not screwed in all the way? Where is this leak coming from? So making sure to check up on that. And here's the QC plate that I mentioned. You're all very familiar with this. When you run it through every time, we want to see that dye and make sure every needle is dispensing a vaccine. So I circled a place here where it does not appear that there's a vaccine dispensed there. So we want to check that particular needle and see what's going on. But a lot of people will run this through, and sometimes they'll go back, check on the crew, and yeah, we ran the QC plate, and they'll see this, but no corrective action was taken. So when this happens, the QC plate, the whole point of it is to troubleshoot. So if you're just running it through, not looking at it and taking action, it's not doing you any good. Also checking for vaccine, we also need to check for sanitizer. That needs to be dispensed at every location as well. So checking up on that. When we're doing all these process checklists, these tips that I've been going over, it's really good to remember that we're adhering to standards, that we need to have something in place. So we provide a lot of guidelines and assistance here in our process evaluations. That's a service that we provide to help train our transfer crew and vaccination staff to make sure that they're vaccinating at an optimum level. And we want to ensure that they have as little risk as possible and as much efficacy as they can in that vaccination. So use that to your advantage. Use that as a tool. Also using good aseptic technique in every part of the handling. This means the thawing, mixing, chilling, and when we're hanging that bag. Really good technique there, because that bag is going to be contributing to the health, and it's going to be in contact with every chick that goes through, just that one bag. So really keep an eye on that. Another thing you want to do is schedule and support training. So this includes for your operators, supervisors, and managers. And we can help out with that. Reach out, get that support schedule. Some sort of plating. We talked about that a few times. And at Zoetis, we can provide this in some sort of mold survey, bacterial, environmental survey, where we can survey and just see what is that challenge load in your hatchery right now? What is that challenge? And where is that challenge at? And how can you take steps to correct that? So those are just a few tools here that we provide that you want to keep an eye on this whole time. So in the beginning of the presentation, we talked about in ovo, how it's a really good way to deliver an effective vaccine. And although it's a great method, we got to remember that nothing's perfect. And in this automation world, it's only as good as how well we manage that process. So you at the hatchery, how are you managing it? And how good is your sanitation? So these are things we need to keep in mind always to ensure that we have good processes in place and that we're checking it out. And that comes down to this key management during the process. There's really 3 areas we need to focus. One is our people. How are our people doing? Are they receiving the proper training that they need? Like your vaccine mixer. How many people are in the lab? Are they using good aseptic technique? The next area is the processes. Are we running that QC plate? Are we checking for bent needles? Is there a smooth injection process? And are we properly handling those eggs? Are we handling them rough and cracking them? Something to check out. And the last piece here is the parameters. So in everything we've discussed, what is our level of measure that we're looking at, and how are we quantifying that? What process is in place? So our QC plates, what are we doing there? Are we doing any plating internally? Do we have a procedure in place? So that's the key here, is there's a lot of things to look for, but they're not doing any good if you don't have the data and you're not utilizing it some sort of regular basis and having corrective measures taking place. So again, I want to put this back into the perspective of, in the hatchery, we're entering this antibiotic-free era where a lot of our previous tools are taken away from us. And so these procedures, the people, the processes, they're becoming more important, and how well we monitor our sanitation. So we need to think through how all these pieces interact. So our egg pack quality here is going to impact our incubation, and all that's going to impact the embryonic development, having a normal hatch window, therefore also having a uniform vaccination because of that embryo staging and transfer. And all of this is going to be impacted by hatch basket sanitation. Those eggs after vaccination are put here, and whatever's on those baskets is going to be in contact with those eggs. And then our in ovo application, everything that we're doing there, that process checklist, checking for bent needles, how well we maintain that device is also going to impact everything. So they're all connected, and the better that we manage each one of these processes, the better it's going to help downstream as well. So hopefully these are a few areas that you could check into at your hatchery. We want to have optimum vaccination and therefore have optimum bird health later down the road and good hatchability. So really what it comes down to in my mind is good sanitation and basic hatchery principles, going back to the basics. And then once you get those things, how are you running your vaccination procedure? Are you doing it to all recommended protocols? And is your staff properly trained? Do they have all the tools they need? So hopefully using those things will help you out. I'll be glad to answer any questions. And if you have any more questions specifically on vaccination, what tools we have to help you out, reach out. Our technical service specialists, our field service guys and gals, they can help you out as well. So thank you for your time, and be glad to answer any questions.
All right, thank you, Josh. Great presentation, a lot of good information there. I actually received some comments during the presentation from people that were watching it and saying, wow, this is really good for us. We have a lot of people that can learn from this, so very good job. Okay, so I've got several questions in here if you want to unshare your screen, and I'll direct them directly at you.
Sure.
Some of the things that you mentioned in there, again, have come up as questions, so maybe we can review them. You were talking a lot about reducing the hatch window because of the effects on the in ovo vaccination. So what is your recommended vaccination time and like a safety margin for the best procedure? Because one of the people on this said that they've received several different recommendations from different manufacturers as the appropriate time to do this. So
sure.
What do you guys think?
Sure. Yeah, that's a great question. And the answer needs to be customized to you, because just like you said, every manufacturer has a different recommendation. And that has a lot to do with what type of incubation equipment do you have in your facility. So there's going to be a big difference between multi-stage and single stage in Jamesway and Chickmaster. Not that either one's going to say it's better or worse, but they're going to impact how quickly that embryo develops and how far along developed it is. Say 18 days. We have embryos from a single stage, multi-stage, Chickmaster, and a Jamesway. They're all been incubating for exactly 18 days, but they may be at different stages of development. So that's what's key there. And if we look at our recommendation, we generally say everything from 17 and a half to about 19 and 4 hours of incubation is that window. Now, the key way to find out is what's best for yours is to having a site of injection done. And so we do a survey and we see where is that embryo being injected at. So look at your transfer, and you could do this on your own a little bit too, just by say, hey, okay, I normally transfer at this time, this hour. Take a couple embryos, break them open, and see what stage of development they're at, and are they consistent across the board. So when we do this, we put an extra dye, a protein stain, into the vaccine line, and we run a couple trays through just to check where that vaccine is being placed, because that's what is critical here, and why we're worried about that development, because we want that vaccine to be put in a few places. If it's in the amnion, that's perfect. That's a great place for that vaccine to be put. It's low stress, and you're going to have good efficacy and immune response from that. The other place is in the embryo itself, in the breast tissue in general is where that would take place. That is also an effective vaccine. However, if your birds are not very far along at all, you may not get into either of those. You could be getting into the air cell, you could be getting into the allentose. And if the vaccine is put into those locations, you will not get an effective vaccine uptake. So that's why it's critical to look at the site of injection. And so I'll give you that window for now, and I know that's not a specific answer. This is when you should transfer, but that's your window, and doing that survey we can help you with will help you adjust your set and transfer times.
Okay, great. Along those same lines, and I've seen this several years ago in the hatchery where they had a huge window. I mean, we actually were looking at the time of transfer, and we were seeing over a day's difference in development. So what negative effects would you likely see if people have that and they're continually using the InnovaJect system, but they have this big window? So what effects to the chicks long term are we going to see?
Sure. Yeah, the longer that window, it's going to have a lot of downstream effects, not just in vaccination, but in production, because when you go to hatch, that same hatch window is going to exist. So you're going to have dehydrated chicks and you're going to have green chicks. So downstream, you're going to see a negative impact on the health because of that stress factor primarily. But if we think about the vaccine as well, remember earlier, where that vaccine is placed is very critical. So if you have a huge, 1 day spread of your embryo staging at time of transfer, some of those early chicks may not be getting much of that vaccine, and some of those really late chicks may be having a really stressful internal needle hit somewhere in the body cavity. So, I mean, that's an exaggerated example, but it can happen in those extreme situations. So, of course, that's going to create more stress for the bird, and you may not have a good vaccine uptake. So that spread is going to be negative in a lot of different ways.
Okay, so those people that are familiar, and you talked about this in your presentation there, about the MBREX score, evaluation score. So what is ideal then? Because you showed like in your 17 and a half, 18, 19 days that they reach a different score. What is ideal for your InnovaJect system?
Sure. So usually about that 3 is kind of, a good target to look for. And so we look for a few things there. We don't want to see any external pips. And we also probably don't want to see any internal pips into the air cell anyway. So we want to look and make sure that yolk sac, we look at it, we want that intestine to be soaked up, but we don't want the whole thing internalized. So in general, that's kind of a good place to be. It's an internal scoring that we use, but let's say about 3 is where you want to be. And so again, if you're doing this on your own and saying, hey, where are my embryos at? The first thing you want to do is say, hey, do I have any pips, internal or external? And if you do, at time of transfer, you're probably too late. Now, if you go ahead and break those embryos open after not seeing any pips, and you see a lot of intestine out, that bird does not have its head tucked under its wing yet, then you're probably too early, and that's the other side of that window. So that's kind of what we want to be between.
Okay. Another question. So a lot of people are using different types of like fumigation or sanitizing equipment in the last days of the hatchery, formaldehyde and different things like that. Does that have an effect when you use the InnovaJect, and you've got a hole in the egg? I mean, people are using that. Do you see any negative effects from that?
Sure. Yeah, that's really common. And I'd say that a vast majority of people who are fumigating are also using in ovo vaccinations, and we haven't seen any negative effects. Now, of course, there are certain products at certain ppm that might be detrimental. However, that just goes back to following the guidelines that's provided by that chemical. But no detrimental effects, and fumigation could be a good control method if you need it.
Going back to the actual vaccination, how long can somebody use the vaccine after mixing it, and what temperature would you recommend? I mean, if they mix it all up, how long do they have?
Sure. Yep. So on our, we have what's called our process evaluation, and it's kind of a way that we monitor all of these things to make sure you're using optimum guidelines. So if you mix that vaccine, you have, say, an hour to be able to use that. And what we require and recommend in our training is when you mix that bag, use a Sharpie, write the time that you mixed it onto it. So when you hang it up, you could walk by and say, when was that bag mixed? And if it's been out for more than that hour, you could say, oh, well, this has been out too long. And then the other critical part here is more so than time, are you coming by and squeezing that bag? So over a long period of time, you're going to have the active part of the vaccine, the part that's actually creating the immunity, those cells will settle in that vaccine bag. And so what that might do is not every dispense is going to have the same amount of cells being vaccinated in that chick. So going by and squeezing that bag, kind of stirring it up, is going to help. Now, in general, if you're keeping it at a good ambient temperature in there and it's not too hot, and you're using it within the allotted time frame, you're not going to run into any of those issues.
Okay, great. That's good advice. Here's a chance for you to use a little bit of promotion for you. Somebody asked, what is the difference between using in ovo versus day-old chick vaccination? Twofold, I guess. One is on the chicks themselves, the vaccine uptake performance, but also, we know there's other benefits to it besides just the chick. Can you kind of touch on those things a little bit?
Yeah, absolutely. So I'll refer back to the one slide that I showed early in the presentation, and that's simply when we do in ovo vaccination, we're getting further ahead in protection than other methods. Because say if you have an 18-day transfer, well, you vaccinated that chick and it's starting to develop immunity before it even hatches. Whereas day of age, they're going to not start developing the immunity till later on. So you have early protection that chick has to things it could potentially be exposed to. Whereas a day of age vaccine, they're going to have a gap in time where they're not protected during an already challenging day in that chick's life, which is the day it hatches. Very challenging time frame. So that's one benefit, is that early protection. There's also been a lot of studies showing that in ovo, that 3-day earlier vaccination is actually more equivalent to 4 days at a day of hatch. So there's kind of an accelerated effect there that we're starting to understand more and more. And I'll say the other big factor here, aside from that jump start in immunity, is the stress of the bird. So when you're vaccinating in ovo, you're not handling that bird. So that's a lot less stress that bird has, again, on an already stressful day, which is day of hatch. So those are things that are on the bird side going to really, really benefit the bird. But if you look at it from a management perspective, you're looking at a labor savings here and efficiency standpoint, because this is an automated process. You can rest a little easier knowing there's more of a consistent delivery, because that machine is developed to where every needle and every embryo is getting the same dose and the same location of vaccine delivery. So spray, day of age, a lot of good technology out there, but it may not be quite as uniform as what an in ovo vaccine is going to be.
Okay. One other question real quick. Can you add any other vaccines to the Merrick's, or what is being looked at in regards to that?
Yes, great question. So Merrick's, I use as a good example because it's a very detrimental disease, has been for a long time, and has a huge economical impact. But because we vaccinated for it so well, we don't see it as much. But Merrick's is now the backbone of newer vaccines. So if you think of our vectored recombinant vaccines, we now have combinations of those, where one vaccine based upon a Merrick's can also provide immunity for other things. But yes, there's lots of different vaccines available, not just from Zoetis, but the other manufacturers as well. But that's where I'd say that the trend is going in technology, is those recombinants and vectors. So you have one product and there's only one cell in there but that same cell is creating immunity for Merrick's and multiple other diseases. So for instance, Newcastle and IBD, those are a couple that are on the market right now.
Would most of your customers or people using any type of in novo vaccination, I mean, from your experience, are they using any contract crews, or most of them using in-house people? I mean, what do you see with that?
Yeah, there's a variety there. Some are using in-house and some are using contract crews. And we see kind of a hybrid as well, where some places are having the lead or the mixer being internal and a QA person, and then the transfer crew themselves being contract. And I'd say both have pros and cons, and so you kind of have to weigh that in your own situation for what is your labor scenario like, and also the cost. The key there is just giving your people or that crew the tools they need to be successful. So one good thing to do for that is, hey, check out your process evaluation. It's a great training tool, and it's also a good checkup on how they're doing. And if you need some additional assistance in training, whatever crew you have, we can help with that.
Okay, great. Back early in your presentation, you were talking about the alcohol being used. In what concentration would you recommend, and what problems might you see if somebody's troubleshooting issues? When would you might see problems, and what would they be if they're
Sure.
off?
Yeah, so the alcohol being stored in the system, yes, it has antimicrobial properties and it'll kill some stuff off, but really you should be taking good care of the machine during your cleaning and sanitation and getting it good and dry, where you've already gotten everything off of the machine. So the alcohol is really being put in there as kind of the cleanup crew to get rid of some of the residual and to prevent new stuff coming in while it's in storage between uses. In general, we recommend a 70% isopropyl alcohol. And that 70% has shown to be not too hard on the machine, a good price point, and has the best antimicrobial effects for what we see. However, many of you have received some emails from us and recommendations where, hey, during this whole COVID situation, we're running low on alcohol. What do we do? You can extend the supply in emergency situations and dilute to 30%. That is, again, just in an emergency scenario. It can still be effective. However, if you're not cleaning the machine good in the first place, that you may not be helping out there. And then the second part of your question was some troubleshooting things. If you don't have the alcohol stored in those lines and in the jugs that you need, think of your air, those HVAC examples that we showed of bad bugs and bacteria that's floating around. That could be putting on your device in your machine. The alcohol is really going to help there and just keep anything from coming into your lines.
Okay. Later in lay, this is a question from one of our international guests on here. The natural immunity to Merrick's using in novo vaccination or day-old vaccination, how does that look later on in life, say maybe 6 months down in life in layer flocks? Is there done any trials with that to really look at if there's any difference between the two?
Comparing day of age versus de novo?
Yeah, like long-term, like maybe 6 months down there on layers.
Yes, that has been looked at. I don't have any data that I'm looking at right now. However, if we look at the uniformity of vaccination and the uptake and protection parameters of in novo, it's shown to be more effective there. So long-term immunity through Merrick's, through a vaccination of any kind, it does exist. Long-term layers, breeders, that kind of thing. And so in novo usually just being more effective because the uniformity is going to be critical there, and that jumpstart in immunity where they're going to be developing it quicker and more robust. So I'd say that long-term effect could potentially extend as well.
Okay. And you talked about this a little bit in your presentation about the ABF antibiotic-free. Have you guys seen any particular challenges? And we talked about what we need to do to have a better hatchery during this ABF thing. Are you seeing any issues with that and extra things that we really need to do that might be really important?
Sure. Yeah. I mean, that's just going to be kind of a challenge. It's hit the industry in pretty much every segment of the integrated process. And in the hatchery, it's no different. I think the highlight and the good thing that came out of this, yes, we lost a tool, but it's also reemphasized how important basic sanitation is, how important our people are, and just those basic hatchery principles. So I'll just emphasize on that there. Good sanitation, cleaning the device well, putting it away clean, and sampling your hatchery, seeing what you're exposed to, because without antibiotics, some of those create a bigger risk than they did before, just because we lost a tool and potentially a Band-Aid it was in certain instances. So we had things that we weren't doing well before, and then that protected us. So now it's, hey, what things can we do better? And sanitation and basic hatchery principles are that.
And I, one of the things I always said with the ABF thing is, first thing you want to do is do all the things you were supposed to be doing in the first place and doing it better.
That's right.
I think that's just important. In response to the question we had that you responded to about adding other vaccinations in there, in terms of live vaccines, not recombinant, is there any potential of using live vaccines in addition to the Merrick's and the Novoject?
Yeah, I would have to check on specifics as far as which ones we have in our offering, but yes.
Okay, so that can be done. You can email later and look into.
Yeah. I could send out a flyer on that. Mm-hmm.
Perfect. Yeah, because some of these we got a lot of questions here. We won't get to them all. So if we don't get to
there's a lot of vaccine options both from us and other manufacturers, and there's just a lot of information out there.
As far as the disinfectants for people who use different disinfectants for hatching eggs as they come into the hatchery before their incubation, do you see any that are better or worse when it comes down to the time you're doing a Novoject and you really want that clean egg? Any recommendations on that, or any things that you see that don't work well?
Right. Well, I'll start off with the things that don't work well, because you see a lot more of that, unfortunately. A lot of the time, because those eggs are coming in dirty. And the problem is, if you're washing an egg with anything, sometimes you could do more harm than good. Depending on, if you're doing a spray, what is the temperature of that egg wash in water? What chemical are you putting on? And is there still organic material present? And are you setting eggs that should never have been set in the first place?
Correct.
So if you're putting really dirty, bad eggs in there, a spray of chemical isn't going to do you a lot of good. Especially, let's say, in a Jamesway buggy, you're putting dirty eggs on top that are exploding and draining organic material and everything else. Doesn't matter what spray you put on when they came in, it's not going to help. So as far as the specific chemical recommendation, I'd say, there's a lot of resources out there that could point you in a better direction and have some really good recommendations on what to do and how much of it. But I think the basic principles of what eggs are you setting and how are you handling those clean versus dirty eggs in your incubator are more important than what you're putting on it.
Yeah, for sure. I had a question. Somebody, evidently a scientist out there, is wanting to know how you came about those bacteria levels that you had on the shells when in that slide that showed the differences. I mean, maybe they're wanting to do it in their own hatchery to see what they have. I mean, do you know how that was done, or was it done way before your time?
Yeah, so that was done before I came on board at Zoetis, but it's a really cool example, and it was kind of theoretical in a way, but it was done by actual sampling of the eggs. And Dr. Chris Williams, he's with Zoetis, he's Director of Technical Services. He put that together, and he's been in a lot of hatcheries and sampled a lot of eggs. And we could do that in a few ways. But when we go into a hatchery, a lot of times at transfer, we will do egg touches and see what the bacterial load and challenge is. So we're looking for a couple things, molds, specific bacterias, but we'll do 4 quadrants on a TSA plate and touch on the round blunt end of the egg where the needle's going to go, and just do a kind of a rolling motion and a quadrant. So we'll be able to sample multiple locations, multiple flocks at transfer time and see what the load is then. Because again, from set to transfer, that bacterial load should be decreasing during that incubation time period. So you can do egg touches on plates. You could do that on your own in the hatchery. And then, of course, you'll need a lab of some kind if you want to speciate or different things like that. You could look for bacteria and mold that way. But Dr. Williams would be able to tell you specifically how they got those numbers. But that was just an example of some common bacterial loads that you would see in an average hatchery, with the theoretical percentage of 99.5 being clean and 0.5% being dirty.
Yeah.
It just really emphasizes that very, very few dirty eggs lead to the majority of all bacteria in a hatchery.
Yeah, it's super good example to see, and somebody was thinking maybe they want to try it, but with the point of what it's showing is great.
Yeah.
You talked about how to clean out the inside of your machines and the lines and everything, how would you recommend, what would you recommend cleaning the outside, the whole machine itself when they're all done, you know, what recommendations do you give on that when they're done for the day and putting it away?
Yeah. So we have placards of how to clean down, and we include that in some of our training as well. But you're going to need some kind of water and nozzle to get rid of all the organic material, some sort of brush, and that brush needs to be cleaned as well. If you have a really dirty brush and you don't rinse it off, then that's going to be bad as well. But if you're using the water and the brush to get rid of all organic material, then that's the first step, getting rid of everything that was on there, and then doing some sort of soap, disinfectant, rinsing, and then putting away dry and letting airflow happen so it dries out in between.
Okay, great. Where's another one? Okay, about the needle, you talk about the needle, and I've seen this myself and wondered and looked at it myself, but is there a certain distance you get concerned about of the penetration of the needle into the egg where you really start to see some problems? I mean, and how do you see that often to where you might get in too deep in eggs, like maybe smaller eggs or something?
Sure. Well, that's the beauty of this device. It's really designed to accommodate different egg sizes, and that depth has been, I mean, studied over, you know, the decades that Imbrex has been injecting in eggs. So the egg size really isn't going to play a part because that locator cup is going to start at the top of that embryo. So more importantly than the needle and the machine itself is how far in development is your embryo at time of vaccination. That's where you see the differences, is that embryo. The machine is designed to go into that correct location. So beyond that, it's where is that embryo at in this stage of development? And that's why it's so important of time of transfer.
Yeah, we had several questions, a similar type of questions that came up in form, and that you basically answered is like, when should we transfer? When should we ovulate? When all this stuff? And really, you're trying to get to that point in time, that certain score time, and there's a range in age, and a lot of factors that affect that. But
that's right.
Yeah, that's important. Okay, there's a few more questions on here that are not directly related to this, but they're certainly important. And just from the nature of time, we'll let Dr. Deines address those by email later, if that's okay. And we thank you all for coming. I thank Josh for participating. It was kind of a fun seminar or webinar to do with Josh. I've known him a long time, so kind of good to see him in this realm. But again, you'll get an email with a link to this webinar. You can watch it again and send any questions you might have. Next week, we'll have another webinar on troubleshooting and maintenance in a single-stage hatchery. So thank you all for coming and participating, and we hope to see you again in future webinars. So thank you.